So it's just a quick one today. I'm going to talk about this circuit diagram. You may have seen this circuit diagram if you're trying to build a mono Varitone circuit, because this is the old one that's potentially came from Gibson in, it says on it 1961, Varitone mono 1961. And all this time it's actually wrong. There's actually a problem with this circuit. If you build it, it won't quite work right. So let's have a look why. So let's start by looking here at the top circuit. So the problem lies within this section where it connects into the pickups. And the top section, you can see the main pickup is one end's connected to ground, which is fair enough. The other end goes to the end of a variable resistor, or a potentiometer to be correct. And then we take off the middle of that potentiometer, we take off the signal. Now ignore that bit, that's just the tone control. So essentially you've got a standard potentiometer, and I'll draw it here. There's positive to there, and then there's your signal. So with a normal DC signal, as you move this up and down, it gets all the way to the top, you've got the whole voltage, it gets to the bottom, you're shorting it to ground and you get nothing. So essentially you've got a volume control. If this is a signal coming in, then you're controlling the volume of that signal. Well, that's fair enough, and that's how this one works. So this top one here feeds straight into the switch, and the switch goes off to the other Varitone circuit. That's fine. The bottom one though is a little bit different, and that's why I first noticed it. I thought, why is it different? Because really you want exactly the same thing. You want two identical pickups, albeit in different places, so you get a different sound. But they should be identical, so why isn't the circuit identical? So again, let's ignore the tone control part and let's draw that one. This time we've got a potentiometer there that goes to ground again here, and we've got the coil across it in the same way. But this time we take, instead of taking that central tapping out as we did before to the signal, actually it joins on. Let's draw the coil in. It joins onto the coil here, and then that whole signal goes out. And this bit here isn't connected, so let's draw that. I've made a bit of a mess of that, haven't I? That bit, you can see the top of there isn't connected to anything. So what they've done, I think, is they've accidentally drawn a dot on there instead of letting it cross, and they've missed out this little line here. So the circuit that they've got, what we're looking at, and let's take this to the mixer circuit. So at the moment, as this is the signal that you're picking off. So what you're doing, as you turn this down, obviously you're shorting that signal across to ground. So you're putting a resistor from the signal down to ground, and as you turn it down, you're shorting more and more of that signal to ground. Now that will work as a volume control. It's not the usual way of doing it, but it will work, because all you're doing is getting rid of the signal. You're dumping it through this resistor, and the lower that resistor, the more you'll dump it. Eventually you get to the bottom, it shorts to ground. So that will act as a volume control. However, when you start mixing them, if you've got both of them working, so let's say now you've got, there's your signal coming in from the top one, and there's your signal coming in from the bottom one. Because they're mixing, as we lower this one down, what's going to happen is, because when we've got both pickups together, they basically short together and both signals get sent through. So it means that as we bring this one down, we're actually shorting that whole signal to ground. So when you've got the thing set up and you're using both pickups, what's going to happen is this control will control the volume of both of them. And that's not what you want. What you want is independent controls. You want to be able to balance the two. You want to turn one up, one down. Well, this one will go up and down relative to this, but this one will control both of them. So you can build the circuit like that, and it will do something, but it's not what you expected. You can't turn this one right down and this one up, because it won't do that. This one will control all the voltage. And I suspect this circuit has been built hundreds and hundreds of times over the years since 1961, well, depending on when this problem came in. And people have been doing it wrong, and they get this strange behaviour, and they just think, oh, well, that's what it does. But in fact, it shouldn't be like that. What we need to do is we connect to the top of that resistor there, goes up to there, and we don't have that as a dot, we have that as a straight across. And in fact, what we want to do is build exactly the same circuit. So ignore that one essentially and just build a second one of those. And like I said, what you do, and I'll draw it in, you draw one up from there, and this one hops across there. It doesn't have a dot on it. So that's, you can see how that's happened. They've obviously, that bit's been faded either over the years or in the original diagram, and then that has become a dot. So we just hop over that, and by doing that, it's now identical to the top circuit, and it will work. So I hope that was useful. Hopefully it stops you from building the wrong thing, or if you accidentally have built the wrong thing and think that it's behaving in an odd way, this is a fairly easy way to connect it, to correct it. All you need to do is shift a couple of the wires across and match it to that. So hopefully that was useful. If you liked it, please press like and feel free to press subscribe as well. Maybe I'll see you next time.